Hello students, welcome to the CBSE Chemistry lecture series. So today we are going to discuss about the 11th standard portion, first chapter, some basic concepts of chemistry. In that particular lesson, we are going to discuss about empirical formula and molecular formula. So we know that the formula of water is H2O, for sulfuric acid is H2SO4, for carbon dioxide is CO2, and NH3 is for ammonia, etc. A formula is a symbolic representation of one molecule of the substance which tells the number and kinds of atoms of various elements present in its molecule. That is called a formula. So now in this case we are going to discuss about what is an empirical formula and what is a molecular formula. Empirical formula of a compound is a chemical formula which expresses a simplest whole number ratio, of the atoms of various elements present in one molecule of the compound. At the same time, whereas in the case of molecular formula, the molecular formula of a compound is the chemical formula which represents the true formula of its molecules, or exact number of molecules, or an exact number of atoms present in a molecule is known as molecular formula. Say for example, I will give the example for this case. You can take a glucose formula. Is C6H12O6 is the formula for glucose. The same time, if you write it as an empirical formula, you have to write like this: CH2O n times. So the empirical formula will tell us about the approximate number of atoms, whereas the molecular formula will tell us about the true formula, or you can say exact number of atoms in the molecules. That is the difference between the molecular formula and empirical formula. Now we will see the relation between the empirical and molecular formula. The molecular formula of a compound is a simple whole number, multiple of its empirical formula. If we express mathematically, we can say molecular formula is nothing but n into empirical formula. This is a mathematical expression of molecular formula and empirical formula, where n is nothing but 1, 2, 3, 4, etc. If we substitute n is equal to 1, what will be the things? Molecular formula is equal to 1 into empirical formula. Suppose if it is a 2, you have to put a 2. So what is that n? How we can calculate the n? N can be calculated by the following formula: molecular mass divided by empirical formula mass. So how we can calculate the molecular mass of a compound? The molecular mass of a compound, of a volatile compound, can be determined by the Victor-Mayer methods. Okay, so if you want to find out a molecular formula, is nothing but n into empirical formula. So this is a formula for calculating molecular formula. Yes, now we will calculate the empirical formula. For empirical formula calculations, we have to have the knowledge of two things. One is a percentage composition of different elements by mass. That is one thing very, very essential. Then second one, atomic mass of each element, atomic mass of various elements. Whatever the elements, if you want to find out, we have to know the atomic mass of all the elements. These two are basic things. Once we know the things, then we have to follow the rules and regulations, or follow the steps for finding the empirical formula. What are the steps involved in this one? There are 5 steps involved in this one. Step 1. What is the first step? You have to convert the mass percent into grams. Convert the mass percent into grams. That is a step 1. Step 2 is nothing but we can calculate the number of moles. Calculation of number of moles. That is a step 2. How can you calculate the number of moles? Moles is equal to mass of element by atomic mass of the element of that element. That is a step 2. In step 3, we have to calculate the simplest molar ratio. Calculate simplest molar ratio. That is the third step. How can you calculate the simplest molar ratio? Divide what you find out in the moles in the previous steps by the smallest quotient or the least value from among the value obtained for each element. This will give us the simplest molar ratio. And the step 4, calculate the simplest whole number ratio. Calculate the simplest whole number ratio. Simplest whole number ratio. That is the fourth step. Last step, that is step 5, you have to calculate write the empirical formula. These are the steps involved in the calculation of empirical formula. Now we will take the problem and discuss one by one. Yes, we will take this problem to work out the answer for this one. 2.38 gram of uranium was heated strongly in a current of air. The resulting oxide weighed 2.806 gram. Determine the empirical formula of the oxide. The atomic mass of uranium and oxygen is given as follows. Uranium 238 and oxygen is 16. First you got to write this element symbol. Element, what is the name of the element? U stands for uranium and the symbol is U, and oxygen. This is uranium. Its symbol is O. And we have to write the percentage, but here the percentage is not given directly. So you have to find out the percentage of uranium. Percentage of uranium is nothing but 2.38 gram of uranium is present in the oxide 2.806 into 100. If we simplify this one, we are getting the percentage, that is 84.82 percentage of what? Uranium. And how can you find out the percentage of oxygen? Is nothing but 100 minus this 84.82 is nothing but 15.18. These are the percentage of what? Oxygen and as well as uranium is given as follows. So you want to write that one. So 84.82 and oxygen is 55.18. And the corresponding its atomic masses is given in the bracket. Uranium is 238 and oxygen is 16. So you have to find out the number of moles. Number of moles is nothing but percentage divided by atomic mass. Percentage is 84.82 divided by 238. Similarly for oxygen is what? 15.18 divided by 16. If we simplify this one, we are getting a answer of 0.35. Here we are getting a 0.94. Then simplest whole number ratio. So when we comparing these two things, which is the smallest one, that is divided by everything. So 0.35 divided by 0.35. Here 0.948 is there. So you got rounded to whole number 95 divided by 0.35. If you simplify these two things is equal to 1. Here it is what? It is 2.66. Then these two simplest molar ratio will be converted to what? Simplest whole number ratio. That means multiply by suitable number. So what is that suitable number? If you multiply with 3, then only we are getting a whole number ratio. That is 3, 1 into 3, 3, and 2.66 into 3 is nothing but 8. So finally we have to write a empirical formula is nothing but, you have to see that one, U3 and oxygen is what? O8. This is the method of finding the empirical formula. The next one, we will take a problem for practice. an organic compound having the following percentage composition. Carbon is 80% and hydrogen is 20%. So you have to write the element first, carbon, and its symbol is C. The another one element is hydrogen. Its symbol is hydrogen. And percentage is given as in the question itself, they are given 80%. This is 20%. And atomic mass, carbon is 12, hydrogen is 1. And find out the moles, number of moles, percentage divided by atomic mass. So here 80 divided by 12 and 20 divided by 1. If you simplify these two things, if we simplify the 80 divided by 12, it is nothing but 6.66 and so on, and 20 divided by 1, 20. So the another one is the simplest molar ratio. How can you find out this? When we compare these two numbers, which is the least quotient, that is divided by everything. So 6.66 divided by these two things is 1, 20 divided by 6.6. How it will come? It will be it is 3.0 and rounded to whole number ratio. Whole number ratio is nothing but is 1 and rounded to whole number is what? 3. So you want to write the element. Carbon is empirical formula. Carbon is C1, hydrogen is 3. This is the way of finding the empirical formula. But the question is what? Now calculate the empirical formula. We have calculated the empirical formula. And also you want to calculate the molecular formula if the vapor density is 15. So you want to go for the next one. So in this case you want to calculate the empirical formula mass. Empirical formula mass is nothing but one carbon atom, its atomic mass is 12, plus 3 hydrogen atoms into atomic mass is 1. So you have to write 12 plus 3, which is equal to 15. This is empirical formula mass. So here if you want to find out a molecular formula, is nothing but N into empirical formula. Okay. Here in this case, how can you find out the N? N is equal to molecular mass by empirical formula mass. How can you calculate the molecular mass? Molecular mass is given as a molecular mass is equal to 2 into vapor density. The question itself, vapor density is given as 2 into 15, that is equal to 30. So you are substituting this formula. Molecular mass is 30 divided by empirical formula mass. You got to calculate, already calculated, that is 15. You simplify it, we can get it 2. Molecular formula is equal to 2. In the place of N, you would substitute what? 2 into empirical formula is C1H3. So therefore C2H3. This is a molecular formula for this problem. Thank you students. If you have any comments, please mention in the comment box. Thank you students.